Hello, my name is Marcos Burgos, current student of the Master in Data Science. Today, I'm explaining the mathematical concept of the gradient descent algorithm. Let's start with a common situation. Imagine you want to buy a new laptop and you need to decide among different stores. Which store would you buy from? Well, it is very likely that you would buy from the store that offers you the lowest cost. This makes sense, and you will see that the concept of the gradient descent is simple as well. Now, in a statistical situation, what line would you use to predict the behavior of the data points? This selection is very complicated, since we have different lines that we can use. Here we can see two lines out of the complete set of lines. Each line is characterized by its own parameter, theta 1 for the first line and theta 2 for the second line. Now, let me introduce the concept of the cost function. The cost function measures the difference between the predicted values that are given by the linear function and the actual values given by the data points. Let's analyze the graph of the cost function. We can observe that it is expressed in relation to the model parameter, what means that each parameter will have associated a different cost value. So, after these concepts, let me ask again, what line would you use to predict the behavior of the data points? The answer is the line with a parameter with the lowest value in the cost function. As in the example of buying the laptop, we select the one with the lowest cost. But now, a new question arises. How do we find a parameter that grants the lowest value in the cost function? Let me introduce the concept of the gradient descent algorithm. That is an algorithm that numerically estimates where a cost function outputs its lowest values. That means it finds local minima by using the gradient descent to approximate the solution. This is performed through a series of iterations. For example, here the initial value moves in the direction of the lowest cost. Then, the algorithm continues moving the parameter value along the direction of the lowest cost. This is only a general explanation of the gradient descent algorithm. Let me detail its behavior by explaining the two features of the algorithm. The negative of the derivative of the cost function evaluated in the current parameter's value. It moves the parameter value in direction to the lowest cost value. For example, here we can see that in this side of the graph, we will move the parameter value to the left. And if we are in this side of the graph, we will move the parameter value to the right, always moving in direction to the lowest cost value. On the other hand, the learning rate helps to tune the size of the steps. For example, a high value of learning rate will ensure a better speed, but accuracy is not ensured. In this other example, we observe that a low value of learning rate ensures a better accuracy in the step, but we will need more steps to get the lowest cost value. Finally, we need to be aware of the trade-off between speed and accuracy performance related to the gradient descent algorithm. Let me show you the progress of the gradient descent algorithm. Here we found the lowest cost value. Regarding to the conclusion of this video, the gradient descent algorithm helps to converge to the optimal solution of the cost function. The learning rate sensitivity introduces the trade-off between speed and accuracy performance. And finally, we can apply this algorithm to train machine learning models with large datasets. Thank you very much.